From a standard form of an equation of an ellipse, let's try to determine the important details. In the previous video, we were able to determine the standard form for the given two equations here. I'm going to write it first. For the standard form of item number 1, it is actually given as x squared over 4 plus y squared is equal to 1. For the number 2, its standard form, let me increase the space here for purposes later, is actually given as x squared over 2 plus y squared over 9 is equal to 1. As to how did this came into being, you might want to look at the previous video for this same lesson, because we actually used a process to determine the standard form. But the purpose for this practice exercise is to determine the position, the length of the major and minor axis, the vertices, center, covertices, and foci of the following ellipses. Now, if we talk about an ellipse, the position could either be stretching horizontally or vertically. The major axis of the ellipse is the line segment which is longer than the minor axis. Okay, the major axis is the line segment connecting the vertices of the ellipse passing through the center, while the minor axis is actually the line segment connecting the covertices of the ellipse passing through the center. I'm talking about horizontally. If we're going to interchange it, it should also be the other way around. And the foci, or the plural for focus, are the 2 points inside the ellipse where we could actually use them to draw the entire ellipse. You could imagine the two foci, and then you simply have a string there, stretch it and draw, you could have your ellipse. So we are going to determine all of these things so that we could graph them later with ease. Let's talk about the position. The position of the ellipse is already given by the standard form itself. The standard form for these two follows the standard form of an equation centered at the origin. Okay? Plus y squared over b squared is equal to 1. So actually, we could already answer the center. Okay? The center for both of these ellipses is at 0, 0 origin. Why? Because they follow the same standard form here, wherein there are no more terms just like h minus h and then y minus k here. Okay, so they are actually following this form. So both of the centers for numbers one and number two is at the origin. So please take note of that. Okay, I'm talking about the position earlier. If it follows where the value of the denominator of x squared is larger than the y squared, just like this is actually equal to 1. Okay, the value 4 is larger than 1 and it's under the x squared, or it's the denominator of x squared. This ellipse is actually stretching horizontally. So let us again write it here: horizontal, horizontal. Right, this is the position. Let's have here the position for the ellipse, horizontal here. Okay, because again, it the value of the denominator, which is larger than the other, is the denominator of the x squared. And being x as the horizontal axis, the ellipse is also stretching horizontally. Please pardon me if I'm going to jump to number 2 for the position so that we could just attack it at once. The position for number 2 is looking at the value for the denominators of x squared and y squared. Here, 9 is larger than 2. This would mean a squared is under y squared. Take note that a squared should always be greater than b squared. Hence, a is always larger than b. So this is now our a squared. And since a squared is now under or the denominator of the expression y squared, the position now here is a vertical ellipse, meaning it is now stretching vertically. So we are done with the positions. And then again, the centers is at 0, 0, since again they follow this standard form here, 0, 0. Okay, for a while it was moved down. Let me move this up. All right. So we are now down. We are down with two items now. Position is already solved, as well as center. Now the length of the major and minor axis is dependent on the value of A and B. The length of the major axis, okay, the length, let me write it here, length, the major axis, okay, its length is actually equal to 2a, while the minor axis is equal to 2b. Okay, again, the major axis, its length is 2a, and the minor axis is 2b. But where do we get this a and b? It is actually given by the denominators here. For number 1, a squared is 4. So if a squared is equal to 4, take the root of both sides. A is equal to positive negative 2. You have two results since we are taking the root of a number. However, a here and b are length. Okay, length, parts of the length. This would mean that we are only going to accept the positive value for a, which is 2. Similarly, for b squared, earlier there was no 1 here, but then again it automatically means that with the denominator 1. So b squared is 1. So b is equal to plus minus 1, and take the positive value for b, which is equal to 1. Okay? Now with this value, our length of a major axis is just twice of a, which is twice of 2 as given here. So the length of the major axis is 4 units or 4 steps. For the length of the minor axis, it's twice the value for b, which is 1. So the value for the minor axis, or the length of the minor axis, is 2. This is for item number 1. Okay, again, let me clear. I might jump from 1 to 2 so that we could just immediately follow the same concepts. So for number 2, same concern. Regardless of whether they are formed vertically or horizontally, the major axis is always 2a, while the minor axis is 2b. But here, this is our a squared. Again, because this is the value larger than the other, which is 2. So our a squared here is equal to 9. So our a is a positive negative value of 3, which is with the value of the positive, you have a is equal to 3. For b, it's 2. Do not worry if it is actually with it's not a perfect square. Nevertheless, it's still a real number. If we're going to take the root, it's positive negative square root of 2, which is really turned down to a positive square root of 2. So with these values, your major axis has length 2 times 3, which is 6. And your minor axis is 2 times square root of 2. Do not give the value in decimal, later probably, but as of the moment, we will have 2 square root of 2 for the length of your minor axis. Again, minor, major. Major is still longer than the minor axis, as you can see with this. And this one here, major axis is still longer than the minor axis. So we are down with this as well. Okay. Our concerns now are the vertices, covertices, and the foci, or other people will just read it foci. Now, if you're going to focus on the summary on our table in our module, we will know immediately what are our vertices and our formula for the vertices, the covertices. The covertices is also called as minor endpoints. And then you have here your foci. But it depends on the position. If in number one, our position is a horizontal, what do you call that, horizontal ellipse. Okay, so our vertices here are actually concerned with the length of the major axis using the value of a. So we are going to use this value of a for our vertices, and definitely the value for b for our co-vertices. And what is that? If we have here a graph, let's just say we do have a graph here. Let's just try to increase this little bit. Let's just say we do have a graph here. You have here line here, and then another line here. And I'm going to draw here an ellipse, assuming this is a very good ellipse, okay, centered at the origin. Okay, the vertices are found here. These are the vertices. The co-vertices are this colored blue. Co-vertices. As you can see, the vertices are endpoints of the major axis. Major axis. Major. And the co-vertices are the endpoints of the minor axis. This is why for the major axis, okay, for the major, for the vertices, we will use A because that is where we have our major axis. For the minor axis, that is actually the purpose for our co-vertices. If we're going to have a copy of this, let's just assume we have a copy, and we rotate it, let's say 90 degrees, and then hence our graph will become a vertical ellipse just like this. This would mean that the vertices is still part of the major axis, and the minor axis will still be with our covertices. The only difference here is the value for our coordinates. Here, our A, okay, and A, the value for A is the horizontal value, which is x. So our vertices, okay, I'm using it here. Our vertices is given as plus minus. Okay, how do I write here plus minus? You have here plus minus a and then 0. Why? Because the value for the y-axis here is 0 since the center is at the origin. So these are the 2 points for our vertices. For our co-vertices, okay, here, it's now the value for the y-axis. That is why you have this. This is just a process if you will forget, okay, if you will get the values. So it's 0 and then plus minus b. This is what happens for the vertices and covertices of this graph. By analysis, the vertices are for the x-axis. That's why the value for a as the length is here. But for the covertices, b is placed on the y coordinate. As for the vertical form, still again, the major axis has A, the minor axis has B, but the vertices and covertices will be turned around for as for its um what do you call this, for its coordinates. So for this is for number one alone, but for number two, the vertices is at 0 plus minus B. As you can see, the vertices here, red is more or less similar to the blue here earlier. So whatever is the co-vertices earlier for horizontal will become the vertices. And by the way, it's not B. I forgot to mention. So sorry for that. It's actually A. Okay, just interchanging it. And for the co-vertices, you have plus minus B and then 0. Let's use this to get our covertices and vertices with this value. So the vertices here, vertex 1 is positive 2, 0, and the vertex 2 is at negative 2, 0. For the covertices number 1, you have here 0 and positive 1 using the value for B. And the covertices number 2, it's not COVID, okay? Do not worry. It's covertices number 1. I'm not scaring you. You have here 0 and a negative 1. As for number 2, it follows this. Since our A and B are 3 and then square root of 2 respectively, our vertices here are it 0, 3. That's your vertex number 1. Vertex number 2 is at 0 and negative 3. As for the covertices, okay, you don't need to memorize the formula. I will give you this. You already have the summary. So you have the square root of 2 is 0. That's your first covertices. And the covertices number 2, again, it's not COVID. Do not worry. It's square root of 2 and then 0. If you're going to plot this in the real number in the Cartesian plane, it will really look like a horizontal stretching ellipse stretching horizontal vertically rather, and for number 1 will be horizontally. These are the items. Don't worry, we will not graph yet. We will have it for another video. Our last is the foci or foci. The foci is somewhere here. Let's use another color. Let's use probably brown or pink if you want to. It's somewhere here and here. Similarly, it's somewhere here and here. It lies on the same axis with the vertices, and it's also part of the length of the major axis. Okay, these are where the foci are. So the foci here will use the concept of C. But where is C, sir? Only A and B are given. There is a formula for getting the value of C. Okay, C is actually with the pair of A and B with the use of our Pythagorean theorem. But let's not be what do you call it? Let's not um, be confused with whether it's C squared is equal to A squared plus B squared. Okay, okay, it's actually the other way around. The formula now is not C squared is equal to A squared plus B squared. The formula for C, as this is actually the distance here. Sorry, this is the distance for C. This is the distance for B. And this is the distance for A. Okay, A distance here. The formula here is actually patterned Pythagorean theorem. But let me not share to you the derivation as this is only for concerned with the practice exercise. The formula here for C is actually equal to A squared minus B squared. Not plus, but A squared minus B squared. Or you could just simply interchange it. You could say B squared, A squared is equal to B squared plus C squared, just like that. But our concern is C, so let's just limit it here. So solve for C, A squared and B squared will be substituted here. You don't need to square A and B here since we already have given earlier A squared and B squared from the standard form. And that would be 4 minus 1, which is a 3. That's your C. And then, sorry, that's your C squared. C could be positive, negative square root of 3. But since we are again using the length, so we are talking about positive square root of 3. Regardless of whether it's horizontal or vertical position, it's the same here. But let's not proceed it yet because we're going to look for the foci. The foci lies in this line with the same line as the vertices. And the vertices are in the form, in number 1, this form here. This is also the form of the foci, but it's not A that will be used. It is actually C. So we have plus minus c and then 0. So the foci for number 1, the focus 1 is at positive square root of 3 and then 0. And the focus of 2, the second focus is actually at negative square root of 3 and then 0. These are the foci for number 1. So we are done with all of this for number 1. Okay. For number 2, we will use the same formula. C squared is equal to A squared minus B squared. Do not interchange them, because if you do, again, the hint is here. A squared is still larger than B squared. So this will become positive here, and the square root of positive is still a real number. But if you're going to interchange the two, let's say B squared minus A squared, since B squared is still smaller than A squared, the value would be negative. And when you take the root of the negative, it will become undefined. So you will not have any focus. So that's the hint of the arrangement. Here, A squared is still 9, the larger value. You have 9 minus 2. So you have C squared is equal to 7. C is equal, sorry, C is equal to the positive negative square root of 7. So your foci, number 1, for a while, it will follow the vertex. So it's not the formula here, but the formula of the vertex here. But instead of A, you will have here actually 0 and plus minus C. And then your foci number 1 is at 0, positive square root of 7. And your foci number 2 is at 0 and then negative square root of 7. So these are the things that you need to determine for you to graph your ellipse. We start with the position because it will help us later on what type of formula for the vertex, covertices, and foci that we are going to use. So we determine whether it's horizontal or vertical. Next, the center is always given by the standard form, since it's vacant here, so it's 0, 0. The length of the major axis and minor axis are also given by the standard form. And we can solve A using the A squared where the larger value of the denominator is. So the other one is B squared. With the use of A and B, we could determine the vertex and covertices depending on its orientation. Position, they are different. Okay, and with the value of A and B again, we could get the value of C for our foci, and still the formula of foci differs on the orientation or position of our ellipse. So please practice on doing this, because when we graph later, we need these ideas and ideals rather. Thank you very much. Please be patient and practice more. Goodbye.